I'd like to take a moment to discuss some of the different types of VPNs that we've got. Historically, VPNs were first constructed, at least when I first saw them, site-to-site using IPsec. IPsec is a standard, so it would work between Cisco and third-party devices. This started to get a little bit tricky when we wanted to do remote access. A site-to-site connection, we would create a static configuration that says to reach this remote network, and typically would be an RFC 1918 address range, we would say to get to that network, go to some other public IP address. And on the remote site, they would have a very similar configuration that's mirrored that says if they want to get to our private IP addressing, come to our public IP address. And you would basically pin up both sides and they would communicate. We expanded this a bit further to allow remote access. And with remote access, what happens is you've got users out there in the field, they'll connect. And when they connect, their local configuration on their laptop per se, or maybe tablet or phone, is going to be configured from the head end or the server side. So the server side always has a static IP, typically resolved by fully qualified domain name. The client side could be coming from anywhere. Could be a hotel, could be a plane, could be a boat. Wherever someone's coming into that network from, they're going to be remote. So only the remote side can establish that connection. Now, because the remote side is connecting into the headquarters or data center, wherever it's connecting to, it's going to receive some configuration details, an IP address, DNS, WIN server, split tunneling policy, firewall policies, things like this. The actual configuration that gets pushed down was historically a proprietary process. So if it was Cisco, you would have a Cisco VPN client. If it was some other third party, you'd have their VPN client. Now, in newer implementations of IPsec with IKE version 2, they've actually standardized that. So you can use a standard VPN client to get in. Or you can use a proprietary client from the vendor, and sometimes that'll give you a little bit more features. With Cisco, we've got AnyConnect, which works on both local and remote access style connections. We'll talk about that a bit more in 802.1x. The other style of connection that's out there is going to be TLS, or Transport Layer Security. This is also known as an Ssl Vpn because SSL was the predecessor to TLS. The Ssl Vpn or TLS VPN is going to work over TCP 443 and then possibly with DTLS, as you see here, UDP 443. The advantage there is if you go through a PAT device, IPsec at layer 4 uses ESP. It has no port numbers. So when he tries to PAT that packet, it goes, hey, where's the port number? And it winds up dropping it. So you can establish the connection, but you never pass any data. In order to do that, you have to encapsulate UDP or TCP. The nice thing about that TLS VPN, or SSL VPN as it used to be called, is that it's going to use TCP as a transport. So considering that this is remote access, if somebody's coming in remotely and they're behind a firewall that we don't control, there's a good chance that firewall is going to allow out TCP 443. There's not a guarantee that it's going to allow out UDP 4500, which is what you would utilize if you're trying to encapsulate IPsec packets to go through a PAT device. It becomes a bit more complicated. So for site-to-site connections, IPsec is king. For remote access, it really goes back and forth between IPsec and TLS. It's not that one is any more secure, it's just the fact that TLS is going to have a better chance of working in environments that you don't control. So less frustrated users, which is always a good thing. So VPNs at a high level, it's going to give us cost savings. What is the predecessor to this? Dedicated links, things like T1s or T3s, where we'd have to schedule a circuit with the phone company, wait for it to be implemented, pay expensive rates every single month. So VPN we can just establish over our existing broadband connection. Assuming that you're going to have an internet connection, we can leverage that for connectivity between different offices, remote users, cloud services, etc. It's wildly scalable. We've got many different types of VPNs that we'll discuss within the course, depending on what your needs are. And of course, it's compatible with broadband technology because we'll just pull a dynamic IP address, maybe from a residential service provider, and that's all that we need. Even using cellular or hospitality networks, we should have the ability to bring up a VPN and get securely connected into our remote infrastructure. There's various VPN use cases. Like I said, site to site is between branch offices, but we also could have connections going into things like data center, going into services that may exist in the cloud, as well as supporting remote users out in the field when they connect into us using the Cisco AnyConnect client.